Okay, so today we are working with section 2.4, more linear equations, and more specifically, we're working with classifications. Now, for the most part, this section is just expanding on what we worked on in what could be considered sections 2.1 through 2.3. Now, a lot of this, okay, we didn't actually go through this in any previous sections, any previous recordings. But what this looks like, and I'll scroll up here to it, is essentially we are solving linear equations. So adding and subtracting things to both sides, multiplying and dividing things to both sides, solving linear equations for a variable. If you'd like to go back and reference our process for this, again, this is the one that I recommend using. This is the same one that we're going to be using in 2.4. We'll go through some examples of this in 2.4 as well. We're going to be going through and using this process, and now we're going to be able to start classifying the results that we're getting, and that's the big kicker with 2.4 compared to these other sections. So looking specifically at the 2.4 material, and again, we're looking at classifications over anything else. This is the big part that's new for this section. So we have three different classifications for these equations. So the general idea behind these things is we are going to be given, here is a problem, and we can see some examples down here if you're looking ahead. So we'll be given a problem. We're going to go through and we are going to solve that problem just like we did in our earlier 2.1, 2.3 linear equations problems. We're just going to be using this process, again, same thing that we used last quarter, to go through as far as we can and solve the equations. Once we have gone through and actually solved the equations, then we are going to actually classify these things. And we have three different classifications that we're going to use, and it's all going to be based on the result that we get at the very end. So our first classification that we have, I'm going to zoom this in here a little bit, make the text a bit larger. There it goes. So our first classification we have is a conditional equation. And these are probably the more common ones that we've seen, or common ones that we work with, more common ones that we see. And its raw definition is an equation that is true for one or more variables of the values of the variable and false for all others. What this means for us in terms of linear equations is that there is one solution. So it means we're starting with an equation, we work it all the way down, and we find x equals a number, or y equals a number. So essentially, we work everything out and we get our standard one solution equation. If we were to look at this thing graphically, or look at these equations graphically, this is where the two lines that we are working with are going to intersect or cross over one another. Again, this is the graphical representation of it. So algebraically, we would find one solution. Graphically, we would find one point of intersection, which is another way of depicting a solution to two equations. Our next classification that we have is an identity. And it's an equation that is true for any value of the variable. So what this one looks like is, this is when we are getting infinite solutions. We have our infinite sign that's going to show up there. So this is what we get algebraically. And this one looks a bit weird when we go through and solve this thing through our standard process that we have before. We're going to go through and see an example of it because I think it's worth seeing. But these classifications we identify as identities. I like to think of this as the equations are identical, identity, infinite. That I is showing up in all of these. If you need a silly little way to remember it, that's the trick that I used that helped me out with it. So from a graphical standpoint, because here we have a graphical version of what this one looks like. So from a graphical standpoint, it means these equations are identical to one another, which means one graph is going to lie right on top of the other one. Again, that identical part showing up and being one of the key parts with these. And then our last classification is a contradiction. It's an equation where equation that is false for all values of the variable, meaning if we go through a process, there is going to be no solution. We will not find x equals a number. We will not find anything like that. We're going to get a really, really weird answer showing up with this. And if we do have that showing up, we're going to get, again, a false equation that's going to show up, and we're going to be saying, well, okay, that doesn't make any sense, so we're going to classify it as a contradiction. From a graphical standpoint, it means that these equations are never going to intersect one another, meaning that they are parallel. So conditional, we are going to have one solution. Identity, we are going to have infinite solutions. And contradiction, we are going to have no solutions. So kind of our quick, easy ways of remembering these things. And again, I think identity and contradiction have the two weirder looking solutions when we go through and find these things out algebraically. Identity is a bit weird, but it makes sense. Contradiction is weird and makes no sense whatsoever. And again, so we're going to go through some examples of this, but remember that when you are looking at these, we generally are classifying the equation after we have solved it and determined the number of solutions that we do or do not have. So when you're going through these on the homework, and you say, I don't know if it's an identity, I don't know if it's a conditional equation, is it a contradiction? Check the number of solutions and see which one matches with which classification. Okay, so I'm going to jump us over to a whiteboard. Here, I guess it's really a blackboard, and we're going to go through and reference these 4 examples. So we do already have the answers in here. Okay, let's pretend we don't actually know this. So a little bit of review and practice with these classifications here. So I'm going to jump us over to that screen, and we'll go through these problems here as our reference for our practice. Okay, so got those there. All right, so our first example that we are working with, and just following the examples that are listed at the very end of that same page. For our first example that we were working with, we are given the equation, zooming it in on my other screen so I'm actually writing down the right thing for you guys. There we go. So we are starting off with the equation 2 times the quantity x minus 7 plus x is equal to 3x minus 14. Now we're going to go through and we're going to solve this the exact same way that we would solve any linear equations from last quarter. And again, you are welcome to reference our process that I have listed for the 2.1 through 2.3 review directly before 2.4 in our lecture notes. So I am going to simplify the left-hand side of this equation, and then I'm going to simplify the right-hand side of the equation if I can, before I start adding, subtracting, multiplying, and dividing things back and forth. So on the left-hand side, 2 distributes through to both terms. Inside the parentheses, I get 2x minus 14 plus x. Let's make that a better 4. There we go. And that's slightly better. All right. 3rd time's the charm. Okay. So again, all I'm doing is I'm just focusing on simplifying the left side of the equation. I'm going to worry about the right-hand side here in a second. So I have 2x minus 14 plus x. So 2x plus x is going to give me 3x. Nothing's happening to the minus 14, so it's going to be written out there. I now cannot simplify anything any further on the left-hand side of the equation. So I'm done there. I look to the right-hand side of the equation now and I say, can I simplify this down at all? Can I combine any like terms? Can I do anything like that? Turns out that I can't, which is fine. So all I'm going to do is just carry that down until I'm at the same point in our process compared to the other side. So now, if I'm going through this, I would say, all right, I'm trying to eliminate the variables terms on one side of the equation. I'm going to get rid of the ones on the right-hand side just because I feel like it. You can choose to get rid of the variable terms on the other side if you would like to. It's your call. So I'm subtracting 3x from both sides. I'm finding that these parts cancel, and what I'm left with is negative 14 is equal to negative 14. So we have an instance here where, okay, I've got same thing showing up on both sides. A bit weird. If you want to take this a step further, you have the option of saying, well, I want to get rid of that 14 on one side of the equation. You can choose to do that if you'd like. And what happens when we do that? These things are going to cancel, and we find 0 is equal to 0. So again, kind of a weird solution that we have showing up here in that regard. So when this happens, this is where, okay, we've gone through and we've done as much as we possibly can to simplify this thing down. Now we need to figure out, how are we going to classify it? Is this a conditional equation? Is this an identity? Or is this a contradiction? And we actually have 3 parts in our process that could give us some hints to this. I'm going to delete a couple of these things here to be able to show that. So remember, our conditional equation says we get a single one solution. We get x equals a number. We get y equals a number. So we do not have that here, which means this thing is not conditional. A contradiction tells us that it's an equation that is false for all values of the variable. And we're looking at this and, well, our final answer is 0 equals 0. That is a true statement. And a contradiction is when we get a false statement, so it can't be that. So what we are working with here is a classification. This is an identity. There we go. It's not doing it. Where's the box? There we go. Let's get the box going with this. Make this look nice. There it is. So we are working with an identity here, which tells me that the left side of this equation is identical to the right-hand side of the equation. That's the way I like to think of it and classify these things. So we actually have 3 lines in this process that would be a giveaway for where we could determine that this thing is an identity. And again, we're looking for where these, for where the equation ends up looking identical to on one side compared to the other side. And we see that show up in our line right here. We have 3x minus 14 equals 3x minus 14. We see it in the line directly after, where we have negative 14 is equal to negative 14. And then in our final line, which I think is the most clear way of seeing it, is when we get 0 is equal to 0. So as we're going through and solving this is kind of the nice part about identities, I think, in this regard. As soon as we see one side is identical to the other, bam, we can already classify this thing as being an identity. And we're going to have an infinite number of solutions to this thing. Meaning this thing's going to lie right on top of itself. Or if we were graphing these things, where these things going to lie right on top of each other. So I'm actually going to jump us over to, actually we'll get to the examples algebraically, and we'll go through the graphical version of it afterwards. Won't jump us around too much all at once. So working with our second example that we had, again, from that same list that we were looking on the other screen. Our second example, we are working with this guy here. So we have 4 times the quantity x plus 2 is equal to negative 2 times the quantity 2x minus 1. And again, starting off with this thing, we're just going to be simplifying both sides down and solving this as if it were any other problem we've done in the past, where we are just solving the linear equations that we have here. So using the distributive property, simplifying the left side down. Got that, can't do anything else. On the right-hand side, I'm distributing through. Make sure you are keeping track of where the positives and the negatives are coming into play and how signs are changing. It's a very big part of the distributive property that a lot of people miss. So now from here, I've simplified both sides down. I'm getting rid of the variable term on one side of the equation. I'm getting rid of it on the right-hand side because I think it's a smaller number, and I don't want to deal with dividing by a negative at the very end. These parts cancel. And from here, I'm subtracting 8. I want to get the variable term all by itself. And then from here, I'm dividing both sides by 8. This up a bit. These cancel out. And we get x is equal to negative 6 over 8. Now, when we get to here, this is the rule of thumb for this class. I'm saying it now. It's going to be true, and we're holding true with this through the entire quarter. You must always, 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 always fully reduce your fractions for your final answer. 6 over 8, or negative 6 over 8, that can reduce down to negative 3 over 4. If you do not fully reduce your fraction answers, unless the problem states otherwise, if you do not fully reduce your fraction answers down, you will be losing points. Okay? Saying that now, I'll be saying that numerous times throughout the quarter. Always fully reduce your fractions. Okay? So we have this here. So now, looking at our second equation that we are working with, we need to figure out how are we going to classify this thing. Is this a conditional equation? Is this an identity? Or is this a contradiction? And based on our definitions that we have and our quick references that we have one solution showing up. We have x is equal to negative 3/4, which means that this is a conditional equation. So we'd go through and we would solve this, and right below it, or if we had a drop down or something like this in the homework, we'd be classifying this as a conditional equation. Okay. So looking at our third example, so someone did post the left-hand side of the screen is cut off. Yes, and that's because unless we unless you do not want to see my handwriting written very well in small text, I do need to keep moving the whiteboard over. So working with our third example, and I'll zoom this out at the very end so you guys can see all of them as well. Third example, we'll get this thing written down here. Okay, I'm just making sure I've got all this written down correctly. I have been known to in the past every now and then write something down wrong. So I want to make sure I'm giving you guys the right information here. Okay, looks like we're good there. So again, we're starting off with this thing. We're saying I'm solving this like I would solve any of the other linear equation problems that we've had in the past. So I'm going through this process. I am simplifying the left-hand side down. I am simplifying the right-hand side down. Remember that when you are simplifying, if you don't know where to begin, PEMDAS, order of operations, tells you how to go through and solve these things. And again, this should be a bit of a review for everyone in that regard, how we go through that. So I'm going inside the parentheses, going inside the parentheses again, and I'm just following the simplification process. Come on. My stylus would like to cooperate with me. That'd be great. So again, I'm just focusing on the left-hand side for now. I'm going to worry about the right-hand side later. So I've distributed that 8 through to both terms. I'm combining like terms inside the set of brackets that we have. And negative 9 minus 24, that's going to give me a minus 33. I can't simplify inside the brackets any further. At this point in time, now I can distribute this 3 on the outside through to everything. And I'm going to get, let's see if my mental math is going to work today. I think it's going to be 96h minus 99. Yeah, that's the one. And I cannot simplify that any further, which is fine. Looking at the right-hand side of this equation, again, I'm just going to simplify that down. This 2 is distributing through. I'm just following PEMDAS. if you need to off to the side. Now, some people like to do this. I'm just going to make a quick reminder of it. The tier system of PEMDAS, make sure you're following that. So we're getting that 10 minus 24h minus 19. We're combining like terms on the right-hand side. So we have minus 24h. 10 minus 19 is going to give me a minus 9. And then I fully simplified the right-hand side, so I'm just going to bring that down to the next line, make sure everything is synced up correctly there. And now I'm going to be canceling out terms, or our variable terms on one side of the equation. I'm going to get rid of the minus 24h on the right-hand side because I don't want to work. I want to get rid of the smallest valued one because I don't want division by a negative at the very end if I can help it. This cancels over here. 96 plus 24. I'm using a calculator off screen. You're more than welcome to do the same thing when you're working with your problems. I would recommend that you write it out for yourself and then use a calculator, but you're welcome to do that. So now that I have all the variable terms to one side, that's great. I want to get all of the constant terms to the other side. So I'm canceling those guys out there. And getting 120h is equal to 9 plus 9, that's going to be 90. And then I do not want 120h, I just want regular h, so I'm dividing both sides by 120. 120s cancel. Okay, h is equal to 90 over 120. Can I reduce this down? Yes, I can. 90 divided by 120. The graphing calculator, MathFrac, is your best friend. Be able to reduce those things quickly. And find that h is equal to 3 over 4. So again, we are being asked to classify this thing. So is this a conditional equation? Is this an identity, or is this a contradiction? And based on the fact that we have one single answer, this is a conditional equation. So again, we'd go through, we'd find our answer here. We determine, yep, we've got a conditional equation, and then we list that at the very end. So we'll look at our final example here. Move this up, I'll make sure we've got space for this. So our fourth example that we have, I'm going to write this thing out, and then we will go through. I've got it over here on my other screen, so yeah. So if we're going through these and you're saying, okay, I'm kind of following your process with this, it seems quasi-familiar, but I don't entirely remember the exact way of going through it, this would be a good indicator of stuff that you need to go back and review then. I'm happy to go through examples of this during my office hour if you guys would like to see that, or see some examples of these or get some explanations on it, but you are going to need to know the process of going through and simplifying and solving these things because it's not going away. Okay, so simplifying the left-hand side of the equation, distributing the 3 through here, distributing the 7 through over here. There we go. And I'm getting 18y minus 27 plus 7y plus 28. Then I'm combining like terms on the left-hand side. I've got 18y plus 7y. That's going to give me 25y. And then negative 27 plus 28. That's going to be a plus 1. Can't do anything else to that, so I'm done on the left-hand side. On the right side, I have this 5 that's going to distribute through to everything over here, and I have this minus 5 that's going to distribute through to everything as well. So I end up getting 30y plus 40 minus 5y minus 5. I'm combining like terms on the right-hand side. I've got 30y minus 5y. Combining those is going to give me a 25y. 40 minus 5 is going to give me minus 35. Got that there. So the left side is as simplified as it can be. The right side is as simplified as it can be. Fantastic. And now I want to get rid of one of the variable terms on one side of the equation. So I'm going to get rid of the 25 on the right-hand side. So minus 25y, minus 25y. And we're getting 1 is equal to negative 35, which is not true. So we have right here our variables canceling out, And we are now left with an equation that makes absolutely no sense because 1 is not equal to negative 35. So it's when we get to these instances and we're trying to ask, how do we classify this thing? Is it a conditional equation? Is it an identity? Or is it a contradiction? And we've already seen a conditional equation. We've seen an identity. This is a contradiction. This is a false statement. 1 is not equal to negative 35. So once we get to this point, we're going to list this thing as a contradiction, and we are done. And so we can and we will be seeing these types of equations and things showing up in this regard. Let's see. Is it? It is. It should be a positive 35. Thank you. Good call, that one. Excellent. Thank you guys for letting me know about that. This is what happens when you rush your work and you're not keeping track of it all. Things happen like this and it's not good. So thank you for correcting that. Appreciate it. So yes, 1, well, even with the sign being gone, 1 is still not equal to 35. So we still are going to be getting a contradiction showing up here all the same. Thank goodness it wasn't that big of a mistake on my part. But these are the types of results that we will get when we start seeing contradiction answers showing up. So we'll zoom us out here. And there's no way I'm going to be able to get all 3 or all 4 of these on the screen at the same time, but I'll try and zoom it out a little bit here for now. So we have 3 or 4 examples, 3 different classifications for them. So again, the identity is when we're going to get something is identical to the other side. So the 2 sides are identical to one another. Conditional is probably our most common one that we see. We get x equals a number, h equals a number, m equals a number, kind of our more traditional ones that we get. And then lastly, our contradictions are just super weird. Number equals a completely different number. That's not true at all. And we get contradictions from there. Okay. So I want to go through, just for the sake of showing this graphically, and this is the last part of what we're going to go through with this section. I do want to go through and show you guys what these things look like graphically as well. So I'm going to jump us back to our notes really quick, so we can take a look at these again. So again, I'm going to reference these same problems that we just worked with. So we went through and saw how we get to these points algebraically. How do we find out it's identity, conditional, contradiction, something like that. So our first part of how we can see these things written out. Now I'm going to go through, I'm just going to type this into a program that you guys can use if you would like to, and I'll reference it here in a second. We want to take a look at what does this mean graphically, so a visual representation of what goes along with this, because I think that's worth seeing at least once. So I'm just going to be typing these equations in, and we'll be finding out what the results look like from a graphical standpoint. So I'm going to jump us over to that screen. Where's that here? Okay, so we've got our WAMAP stuff here. So the site that I'm referencing is geogebra.org/geometry. It's a free website. You are welcome to utilize this if you would like to. I think it's great for visuals, for inputting things to see what graphs look like. It's also really handy for working with geometric shapes and whatnot as well if you are trying to calculate things with that. But that's not the main point of what we're doing here. We're going to be working with our classifications of these things. So I'm referencing our first example that we had. So the way we're going to end up seeing this thing visually, I'm going to type these things in, the equations into this, and we'll see what the graphs look like. So our first equation, we have to separate this out to be the left side of the original equation is going to be its own kind of equation that we're typing in. So I'll type this out here and I'll show you guys what I mean by that. And you can see the graph kind of change as we're going through and typing this thing in, which I think is really cool. So we have our top part here is the left side of that equation in part 1. So I can change the color on this thing. Something other than gray. Let's make this one blue. And now I'm entering in the right side of the equation. I'm just going to put that in as y is equal to 3x minus 14. And we see that it was fine, and suddenly now it's right on top of the other one. Here we go. It's now lying right on top of itself. So I'm going to zoom this out. I'm doing this just by scrolling the mouse, and we're seeing that as far as we scroll out, this thing just keeps on being the exact same all the way out here. So again, these two things are identical, which means they have an infinite number of solutions. It's a way of saying, where do these two lines cross over each other? Well, they cross over everywhere. That's the identity part. Okay, it's like I meant there. So that's our visual representation of our first equation that we have. So looking at the second problem that we worked with, again, I'm going to type in the left-hand side first. And I'll type in the right-hand side directly below it. It's automatically putting 2 and 3 in there, but I'm going to change that here in a second. So we have 4x plus 2. So our first equation graphed there. Our second part of the equation, we were given negative 2 times the quantity 2x minus 1. Okay, and this, I don't like this gray showing up as much. Let's put this one in red so it stands out. There we go, some red, white, and blue showing up, especially given that Independence Day is showing up soon. So as we're looking at this thing, we're seeing, okay, so I've got the left-hand side of the equation in blue, the right side of the equation in red. And when we went through and solved this thing graphic or algebraically, we found that there is one solution. We find that the equations cross at one point. And it turns out that they do. It's right here. Let's see, I think GeoGebra, yeah, there we go. We can see where these things intersect one another. I get our answer there. Okay. So again, visually, we can see that they intersect at one particular point as it's written in there. I'm going to take a look at let's take a look at the fourth example, just because I want to at least show it, and then we can, I'll open things up for questions here. So I'm typing in the left side of the equation. This is the one that had a bunch going on with it. Now, as I'm typing this in, you might be saying, okay, well, you're putting x's in there when the original, now I'm putting x's in there, when the original problem that we have been given is having us work with y's as the variable. And why are you doing that? And the reason I'm doing that is because GeoGebra is a little bit picky on what we use and define our variables to be in this problem, or so it graphs these things. So I'm doing a slight change to the original problem only so I can make the program work. Because again, I want the nice visual that goes along with this, but I do need to follow its coding that it has, which I do not have the ability to adjust on my end. I should probably actually type in there and checking it. Okay, so we get that. And as we're looking at these things now, again, graphically, we're seeing, all right, well, these things are running parallel to one another. They're not actually touching at any point at all. I can zoom out and see they're still parallel, still parallel, still parallel. I could keep going, but I think you guys are getting the idea of this before it becomes just a mess of what's on screen, essentially. So again, this is the visual representation of what we get when we go through and solve for these things algebraically, and what these classifications look like on a graphical level. Okay. So this is everything that we have. I'm going to jump us back to our notes here. This is everything that we have for our 2.4 material. There are additional, this is normally for if we have the in-class stuff, we have additional problems if you would like to go through and practice these on your own or whatnot. There are answers at the very bottom of the screen down here, if need be, but those are available to you. So I am looking at our time with where we're at here as well. So I'm going to stop our recording for the 2.4 material, and I'll take some questions if you guys do have any of them over the 2.4 stuff, and we will go from there. Let's see, stop recording.